today we're going to be doing 3.6 linear applications. So make sure to follow along in your notebook and you can fill in the notes as we do it right here. So let's read this. It says, sometimes applications can model a linear relationship. For example, suppose Mrs. Teapot decided to record the growth of her son Chip every 3 months. When he was born, he was 19. Let's go ahead and underline some information here. It says he was 19 inches tall. Exactly 3 months later, he was 21 inches tall. See the growth chart below. So let's go ahead and look at this chart. We have our age, which is in months. So we'll put an M for months. And we have his height, which is in inches. So let's put IN for inches next to height. And says, consider the ordered pairs. We have the age in months, which is our X. And we have the his height, which is our Y. So this is our ordered pair. And that's what we have over here in this chart, right over here. So it says, what is his growth rate, the slope, for the first 3 months? That's one thing I do want to point out that we want to note is the growth rate is the same as, is also known as the slope, which is also known as the rate of change, which you will see in a bit. So let's write that at the top. Slope equals the rate of change, meaning that's the same thing. So if you ever see find the rate of change, they're telling you to find the slope. Okay, so slope equals rate of change. So it says, what is his growth rate? See, there's that word rate, right? Just like what we wrote up here. What is his growth rate? So let's find the slope for his first 3 months. So his first 3 months will be 0 to 3 months right there. So let's go ahead and set this up. We remember our y2 minus y1 over x2 minus x1. So let's go ahead and write this. So we have 21 minus 19. Let me change a font here. Okay, so 21 minus 19 over 3 minus 0. And that gives us 2 over 3. So we have our slope of 2 over 3. Now it says, what is his growth rate for the 3 to 6 month time period? So let's go ahead and do his 3 to 6 month period, which would be right here. So that would be 23 minus 21 over 6 minus 3. Again, we're getting this information from the chart right next to this this. So we have 23 minus 21 is 2. 6 minus 3 is 3. So we found the growth rate, also known as the slope, which is 2 over 3. Now it says, what is the growth rate for the 6 to 9 month period? So let's go ahead and do 6 to 9 month period, which is right there. I used the green marker for this one. So we have 25 minus 23 over 9 minus 6. Now we have 2 over 3. So therefore, our growth rate is also 2 over 3. So it says, since the slope remains the same for all data, this is a linear relationship. So let's go ahead and write that down, a linear relationship. So again, remember we used for all of these to find the rate, the growth rate, we used the slope, which was the m equals y2 minus y1 over x2 minus x1. Okay, so we found the linear relationship here. Now it says, write the linear equation for Chip's height in terms of his age. So we want a linear equation. Remember our linear equation, we have y equals mx plus b. So our b is our y-intercept. This is going to be his starting height. So when he was born, what was that height? Well, he was 19 inches. So we're going to put 19 here, bring down our x, bring down our y. And now we have to fill in our m, which is our slope. So what was our slope that we found up here? Well, you can see we found 2 over 3 for letter A, B, and C. So let's go ahead and write 2 over 3 for the slope. Let me get my marker back up. Here we go. Okay, 2 over 3. So his linear equation for his height in terms of his age is y equals 2 over 3x plus 19. Now, if this relationship remains linear throughout his life, how tall will he be when he is 2 years old? So 2 years, we know 2 years equals 24 months. And we want to switch that to months because, again, when we look at our chart, it is in months. His age is in months. Therefore, his age, which is also our x, right? Our x and our y, so our age. The age is our x, so that means x equals 24. So let's go ahead and put that into our linear equation that we found. So y equals 2 over 3, and instead of x, I will use 24 plus 19. And we get, let's see, 2 times 24 is 48 divided by 3, which is 16. And you can use, let's see, I'm not sure if you're going to be able to use a calculator on this section yet or not. I think so, but at this point, you could still do it by hand. So 16 plus 19, that gives us 35. So 35 inches. All right, do you think it is reasonable that a person's height and age will remain in a linear relationship? The answer to this would be no. Why? Because eventually everyone stops growing. So let's write that down. Eventually, you stop growing. And also, it doesn't also account for any growth spurts because you don't always grow evenly throughout your life. So let's just put growth spurts. Growth spurts. Okay, let's go to the next part. It says now we're going to switch scenarios here. It says the body length, y inches in inches of a walrus can be modeled by y equals 5x plus 42, where x is the calf's age in months. So we know x is the calf's age in months, so I'm going to just put an x right there to remind us. It says, what do the slope and y-intercept represent in this graph? So we have, remember, the body length is the y, and the calf's age is the x, and we know that 42, this 42 right here, must have been the starting length, right? So it says, what do the slope and y-intercept represent in this graph? Well, we have, let me get my colors back up here. Okay, we have the y-intercept here. So our y-intercept is the length of the walrus at the time of birth. So the length of the walrus at birth. And then we have our slope that we can see here. So that 42 was the length that he was when he was born. And also this 5, well, that is our slope, right? Because we have y equals mx plus b. So our slope is how much the walrus grows in 1 month. The walrus grows in 1 month. So we're not using number values for these. We're just explaining what each thing represents. Now it says use the equation to estimate the body length of a calf that is 10 months old. So we know here our x equals 10. So let's go ahead and put that into our linear equation. Y equals 5. Instead of x, we will put 10 plus 42. And if you solve that, 50 plus 42 equals 92 inches. Now, what is the age of the walrus if it is 200 inches long? So we have its length, so therefore that is our y equals 200, and we know that from the information they gave us right here at the top. So we have y equals 200, so let's go ahead and plug that into our equation. 200 equals 5x plus 42. Again, we're still using the same equation that they gave us up here. So let's go ahead and solve. So we have, let's solve for x. So we need to move that 42 over. And we end up, these cancel out. We bring down our 5x and we have 158. Divide by 5 on both sides. And we end up with x equals, I'm going to come up here, x equals 31.6. Again, it says, what is the age of the walrus? Well, we have, oh, I'm supposed to write 31.6 and I wrote 0.5. So let's put 31.6. And so what age? Well, we know this walrus is anywhere between 31 to 32 months of age. So let's go ahead and put that. All right, let's go ahead and go on to linear inequality application. So now we're working with inequalities. It says 6 data points are given below. So we have these x data points right here, and then we have our y data points right here. Okay, so our question at the bottom right here said, or right below that chart, says which of the following linear inequalities can be used to represent the data set. So which of these linear inequalities can be used to represent the data set? Well, in order to figure that out, we're going to have to plug in some values here. Okay, as we look at these values, I want you to notice something. Let's look at these linear inequalities right here. If you look right here at numbers 1, 2, 3, and 4, I want you to notice that number 1 right here, I'm going to highlight it yellow, x minus 2y is greater than negative 6. But look at number 3. They're very similar. This one says x minus 2y is greater than or equal to negative 6. Now let's go ahead and look at number 2. It says x minus 3y is less than or equal to negative 3. And then number 4 says x minus 3y is less than negative 3. So we can conclude right here that number 1 and 3, let's make that 3, are similar. Right, so let's write that down, are similar. They're not the same, but they are very close to each other. And then we have number 2 and 4 are similar to each other. Similar, there we go. Okay, so we can just use those two equations to help us out. So let's go ahead and fill in for number 1 and 3. I'm just going to take number 1. My x minus 2y is greater than negative 6. And let's go ahead and fill in that x and y using the values that are given to us in this list of points. So we have x, which is negative 1, and then minus 2, and put negative 1, minus 2, and then for y I put 1. Is greater than negative 6, and then again I'm just going to be filling in my points. 8, then minus 2, and then for my y, that's a 6. Again, I'm getting all of these from the chart right next to it. Now I have negative 4, and then the negative 2 times 0 is greater than negative 6. Now I have my 6, and then negative 2 times 4 is greater than negative 6. Now I have my negative 8, and then my negative 2, negative 1 is greater than negative 6. And then I have 3, and then Here, I'll shrink this down. Minus 2 times 2 is greater than negative 6. So let me see if I could shrink this down. Will it let me? Probably not. So we'll just have to read over those words. But okay, so let's go ahead and solve these really quick. Are these true or not? So negative 1, and then we have, what is that? Minus 2. So negative 1 and negative 2, right? So that would be negative 3 is greater than negative 6. Yes, that is true. Then we have 8, and we have negative 12. That would give us negative 4. So is negative 4, let me write this down on here. Is negative 4 greater than negative 6? Yes, it is. Negative 4 and 0. So negative 4 is negative 4 greater than negative 6. Yes, it is. So let's go ahead and put that. Then I have, now we have 6 and negative 8. Well, 6 and negative 8 would give us negative 2. So is negative 2 greater than negative 6? Yes, it is. So let's go ahead and check that off. Now we have negative 8 and positive 2. That would give us negative 6. Well, so again, we'll write negative 6. So is negative 6 greater than negative 6? Actually, no, that would not work. Because it's not greater than. It's equal to, but not greater than. And last we have 3. And, well, that would be negative 4. So that would be 1. Is 1 greater than negative 6? The answer is yes. So let's go ahead and give that a check mark. And again, that was 3, negative 4. So that would be negative 1 is greater than negative 6. So basically it works, right? So this works for, it works for everything that is greater than or equal to negative 6. So we know that 1 can't be an option. So we can't use 1 because it won't work. But because it's because we have this one right here that was greater than, but it is equal to, right? So we know that 4 is not 4, number 3 right here. Number 3 is definitely an option. So now we have to do the same thing with groups, with the other group. So let's go ahead and do, this time I'm going to use the x minus 3y is less than or equal to negative 3. And let's go ahead and fill in those. So we have our negative 1, and then our negative 3, positive 1 is less than or equal to negative 3. So let's see, negative 1 and negative 3, that would give me negative 4. So is negative 4 less than or equal to negative 3? Yes, it is. So that checks out. Next one is 8. Then we have negative 3 times 6 is less than or equal to negative 3. Is that true? So 8 and negative 18, that would give us negative 10. Is negative 10 less than or equal to negative 3? Definitely less than. Let's go ahead and fill in the other one, negative 4. Then negative 3 times 0 is less than or equal to negative 3. Is that true? Well, negative 4 and 0, that's negative 4. Is that less than? Yes, it is. Let's go and do the next one, 6. And then we have 4 times 4. Am I doing that one right? No, 3 times 4. Thought that looked wrong. That would be a negative 3 times 4 is less than or equal to negative 3. Okay, so 6 and negative 12, so that's negative 6. Is negative 6 less than or equal to negative 3? Yes, it is. So I'm going to check mark that one. Now we have negative 8, and then negative 3 times negative 1 is less than or equal to negative 3. So negative 8 plus 3 is negative 5. Negative 5 is definitely less than or equal to negative 3. And last we have 3, and then minus 3 times 2 is less than or equal to negative 3. Well, we have 3 and negative 6. That would be negative 3, which is less than or equal to, so yes. It says definitely these will work. However, we know it will not work for the less than negative 3, because remember we had that one that was equal to. So it won't work for the less than 3. So we know it definitely will not work for number 4, but it will work for number 2. So in that case, our answer will be C, 2 and 3 only. Okay, let's go ahead and do number 4. Jerry wants to have a maximum of $100 cash at the ticket booth when his church carnival opens. So let's go ahead and underline some information. $100 cash. He will have $1 bills and $5 bills. If X is the number of $1 bills and Y is the number of $5 bills, write the inequality that models this situation. So again, we're going to write our inequality here. We have our X and our Y. So we know that $1 bills are represented by the X's, plus the $5 bills are represented by the Y's. And our inequalities, well, we want those dollar amounts to add up to 100. So we know they have to be equal to, so these dollar amounts must be less than or equal to. They can't exceed the $100 because that is the goal amount. And that is our inequality. Now let's go ahead and go to number 5. Tula has $20 to spend at the used book sale. So let's do $20. So we know this person can only spend up to $20. So it can't exceed that $20, but it can be equal to it. Hardcover books cost $2 each, and paperback books cost 50 cents each. If X is the number of hardcover books Tula can buy, and Y is the number of paperback books she can buy, write the inequality that models the situation. So we know X represents the hardcover books, which are $2. So we will do 2X plus the paperback books are our Y's, and those are 50 cents. So let's do 0.50 Y. And that is our inequality.